So again, good day to everyone, all of you. We are now uh, discussing the topic on developing deep learning models, for time series. As you can see from the module's title, it's about developing deep learning models for time series data. And you can see from your module that you have three notebooks that are already published: the MLP time series, the CNN time series, and the LSTM time series. I'm not gonna use the notebook because each notebook is a complete set for developing each type of model for deep learning. However, I managed to compress them in one notebook, and I'm using that notebook now, uh, which I call it the deep learning time series forecasting. Okay, so at the first part of the discussion, we will be covering developing MLPs for time series forecasting. And in this topic, we try to demonstrate uh, how we will be able to apply multi-layer perceptron model, for a very small contrived time series data set. So we will just give some small data set, and then later, in some of our examples, we will be providing some real world data set, especially for univariate and multivariate time series data. And remember that our goal today is to just develop the deep learning models and not focus um, on the accuracy of the model that we are trying to develop. So we're not going to optimize the deep learning model for our examples. So let's start with the univariate MLP models. So we will be covering univariate and multivariate time series data for multi-layer perceptron models. So we have already discussed the concept of multi-layer perceptron, and which is we believe that this is the foundation for some simple neural networks, that are capable of understanding and learning from any type of data. From the past lessons, we discussed that the multi-layer perceptron has the ability to classify, and then it also has the ability to predict. And MLP models can also be used for time series forecasting problems. Especially for this first part of our topic, we will be discussing how we can apply the MLP for time series forecasting problems. So univariate time series, these are data set. No? We all know that these are data set that are very simple. It has a single series of observations. No, we call it a feature. So it's just one feature, and it is ordered in terms of time, or we call it temporal ordering. And MLP can be used or applied to learn from this particular series, using past observations, and then predict the next value in the sequence of the given time series data. Now, you can see from here, there's a code here called the univariate data preparation. We managed to discuss this last time, and I already explained what this function here, the define split sequence function. No? So this function that we have here is a very important function, no? And you will see that later we will be updating this function to cater to other types of time series data. For example, we can use also this for multivariate time series data. And even if we are trying to predict a multi-step function, or that means we want to get a value, more than one value in the future of a sequence, now we can still use this particular split sequence function na ito. Okay? So, as you can see, this is a function that takes a univariate sequence and a number of time steps. So, the input that we have is the sequence and the number of time steps, indicated by n underscore steps. It took them as the inputs, and basically it returns an array for the x values and an array for the y values. Now, the function splits the sequence into multiple samples, and each sample has n number of steps as the number of time steps. And the output of the sample is the next value in the sequence. So how does this function works? The function first initializes two empty lists. No, we gave the name as capital X and small letter y, which will be used to store the input and output parts of the pattern for each sample. And then you can see from the function that we have a loop, no? So in the loop, we can see that the function loops through the sequence from the first element to the last element minus the number of time steps or n steps. And for each iteration, it will check if the end of the pattern, and we name it as n underscore ix, is within the sequence. If it's not, then the function will break out of the loop. Now, if the pattern is within the sequence, then the function will extract the input part of the pattern, or we call it the sequence underscore x, right? From the current position, which is the I, up to the end of the pattern, which is, you can see from here, this is the end of the pattern. So, n underscore ix. And the out part of the pattern, which is sequence underscore y or sec underscore y, is the value at the end of the pattern. Now, the input and the output parts of the pattern are typically will be appended, as you can see from the function. They will be appended here, okay, to the x and the y list respectively. And then finally, the function will return the x and y lists as numpy arrays. So basically, we can use this function for splitting a univariate sequence into samples. So let's say perhaps we have a series of an array of 10 with an interval of 10. So we have 20, 30, 40 until 100. So we have a length of 10 from this series. And you can see here that we have printed the shape of the series. And then we use the function split sequence and provided our series as our input. And then for the n number of steps, we will have 3 as the value. So I'll try to connect to Google Colab now so that I can run the notebook. And as you can see here, after splitting the series, we would like to print the shape of the x and the y. And then summarizing the data that we have, we can take a look at the data by looping on our x values. So we will just be getting the x values, and we will print the content of our x values as well as the y values that we have created so far from the data set. And as you can see from here, the output are the following. The shape of the series is 10 by 1. And the shape of the x is 7 by 3. So where is this coming from? So this came from the data preparation. We managed to provide, looking at the number of sequence as the differentiator here, meaning it will take effect whatever number of steps that we have, it will divide the series. No, since we divide it by 3 samples, no, we now have 7 results. No, given the range that we have is only 10. Okay, so until 100, or yes, the length of the series is 10. No? So 10, 20, 30, that's our input. So we have one sample here with 3 time steps. Another sample is 20, 30, 40 with 3 time steps. And you will notice that the Y values are the next values, no, coming from the sequence itself. So we took the Y value here as an output value coming from 10, 20, 30. Of course, the next is 40. And then 20, 30, 40 as input, we have 50, and so on. All right? So that's the concept of how we can split a univariate sequence, now, given this particular sequence here. Now, if you take a look at that, and we try to change the number of steps. Now, for example, we want the steps to be equal to 4. And if you try to run that, running that will give us the following. So now how many samples do we have? We only have 6 samples, and each sample has 4 as the number of steps. So we have 4 values because we took 4 as the number of steps. All right? But the same thing, if we have this first sample as our input, the next value after the last number will be our output value. Now you can see that the shape of our x is equal to 6 by 4, and the shape of our y is now equal to 6 by 1. All right, we have 6 values for our output values. And if we try to change again, for example, we want to change it to 5. How many do you think we will have samples after this? So we try to run that, and now you will see that we have 5 samples with 5 as the number of steps, for each sample. So dividing this 10 element by 5 samples, we now have 5 samples with 5 number of steps for each sample. So depending on how we look at it, but definitely the code that we have is really working. So it's working, and we managed to split our sequence, especially our small contrived data that we have. So we managed to split it into 5 as the number of steps. And definitely we have acquired this number of samples that we have here. All right. So you can see that definitely we can now apply the following into an MLP model. And as you can see here, the dimension that we have here is equal to 3, because the first example that we have is to prepare our data into 3 as the number of steps that we have. So I'll try to run this again, and you can see that we have 7 samples again and 3 time steps per sample. To apply our MLP model, we just have a basic model. We just have an input layer, and our input dimension should be equal to the number of steps. And the number of steps here is equal to 3. So if you want to change, for example, you decided to make this as equal to 5. So you have to change also the number of steps here. It should be equal to 5 as well. Okay, so you can see that this MLP model is a very, very simple model. We just have an input layer, one hidden layer, and one output layer. And then we printed the summary of that. And as you can see, so this is the summary of the model that we have for this particular model. All right, so the trainable parameters are 501. And now we feed the model, okay, feeding it with the input values. Remember, our input values size is 7 by 3, and our y is equal to 7 by 1. We feed it to the model with 2,000 epochs. So it's gonna take some little time. So we'll just have to wait. And as you can see now, it's okay. So for instance, you have a value of 80, 90, and 100. So definitely, this is the last sample set that we have based from our data set. No, actually the last sample set is 70, 80, and 90, and our output value is 100. What if we try to make an input of 80, 90, and 100? Supposedly, our output value should be equal to 110, correct? So we try to execute that cell, and you can see that the output is equal to 110. No, never mind the regularities here. No, kung may sobra man, it's okay, but we are not focusing on the accuracy of the model. Okay, but definitely to be able to do that, no, we place our input here, and our input size is of the following range: 89. Actually, you have three. We have one sample with 3 time steps, no, as the number of steps, and then we reshape our input to 1, and depending on the number of steps, and then we use the predict function and inputted our x input, and then of course we don't want to see anything that happens there, so it's gonna take now the output. And if you try to change, for example, you want to change this, no, for example, you have 150, and then the next is 160, and the other one is 170. Our expectation is that this model will be able to provide the proper prediction. So our prediction should be equal to 180. And let's see if the model will be able to do that. And as you can see, it was able to predict. However, we have 181.6. So medyo may labi siya ng konti. But definitely our model now, no, it's a simple multi-layer perceptron model that was able to definitely predict the next step, no, coming from this sequence. Now, if we have a sequence that has an interval of 10, because this is what we fed, no, from our model based on the data set that we have. Now, even if you put, no, even if you put other samples that were not seen by the model, it was able to predict the next sequence, no, from this input that we have. All right. Now another example is this. No, what if your raw sequence is something like this? You will notice that the input sequence are doubled each time. Now, for example, the first sequence is 20, now it's 40, and it becomes 80, and then 160, and so on, up to 10,240. So we're gonna use that, no? Of course, we need to provide the proper documentation for the library, and then we need to provide the function for our data preparation, and then the row sequence will now be the input value for our split sequence function. No, and then the number of steps is equal to 3, as you can see. All right. Now let's try to make it 4 para naman maiba, no? And as you can see now, the number of steps is equal to 4. Okay, so definitely the order of the shape will now be somewhat different, no? And then we're going to typically change this, no, as our input value. It's because here we only have the shape of 3 as the number of steps, no? And this is our array. Our input value is 500, and then 100, and 2000. So we are doubling the first number, and the next sequence should be doubled of that, no, from the previous one. So definitely we need to add more as 4,000 because it's the double of 2,000. All right. Now that we have 4 as our input values, no, typically the same as our number of steps here, maybe we can run this, no, providing our expected output here should be equal to 8,000, right? So we are expecting that based from this simple model that we have, now we will be able to provide 8,000 as our output value, no, for the prediction. And let's try now based from this raw sequence as our input sequence. Maybe we can teach the model to understand that we are trying to double each previous sequence, so that if we have this particular input sequence here, we will have to expect that the last input value should be doubled. All right? So let's try to run that and we'll see what's the answer. So it's taking time, but definitely we'll try to see now the result. And as you can see, it's almost 8,000, no? 7,999.875. So definitely the model was able to predict the next sequence from our list. Now it's really easy to understand this, no? And the model was able to understand this because our uh, data set is somewhat linear, no? So meaning uh, the design of the data set that we have is a time series that typically has a linear type of um, of data. So it's really easier for the model to understand that, because the model can understand that I can see that the data is somewhat in line with a typical line, no? Somewhat linear. But what happens when we have a data that is erratic, no? So meaning, for example, if you have a data set like the COVID data set, no, where, for example, in the Philippines, we have this value of infected people 100 for this particular day, and for another one we have 50, and then the other one we have 3,000. So that's very erratic. What if we have something like that, as a data? So if the data is nonlinear, so the model could somehow be uh, fixed, no? So that's the best thing that we can do. But definitely in providing the data preparation, we can still use this for preparing our data into a number of splitting it in a sequence, no? Particularly defining the number of steps that we have. No? Even if we change the number of steps, no? For example, we change it to 3, no? And then we remove this, so we are expecting that our output will become 4,000, no? Because 4,000 is the next output here. And as you can see, if we try to run that, and let's wait for the output, what do we have? You can see from the output that since we are expecting 4,000, we have 4,000, as you can see. So the model, even if we change the number of steps, no, so it doesn't affect, the model, how it recognizes the pattern of the sequence, that it has splitted. As long as you define the proper way, on how you reshape your input, for your model, so definitely it works, no? Now, what about for multivariate MLP models? So again, univariate are for single observation or single features. But if you have multivariate time series, so it means that the data has more than one observation for each time step. And there are two main models that we may require with multivariate time series data. They are multiple input series, and the other one is multiple parallel series. Let's start with multiple input series. Now, a problem may have two or more parallel input time series and an output time series that is dependent on the input time series. So meaning, that means it's very straightforward to understand that, for example, you have a data set. No, in this example, we have input sequence 1 and as our first input value, and it's running in parallel with in sequence 2. So the value of our sequence 1, you can see that the numbers are ranging from 10 to 90. That's 9 as the length of the 9 as the number of the length of the series, no? And then on the other sequence, we have 15 up to 95. So the interval is in terms of 10. So the next number is 25 and the other one is 35, and so on. Now for the output value, as you can see, if you have a multiple input series data, So that means that you have two, in this case, we have two input time series, no? And we have one output time series, which are dependent on the input time series. So you can see here that we are using the sequence, the input sequence 1 and the input sequence 2 to generate our output sequence. So which means um, the output sequence time series is dependent, no, on the input time series that we have, no, particularly in input sequence 1 and input sequence 2. Now, the input time series are parallel because each series has an observation at the same time step. So meaning if you have 10, we have 15. If you have 20, you have 25. If you have 30, you have 35, and so on. All right? So they're running parallel. Now, we can demonstrate this with a simple example of two parallel input time series where the output series is the simple addition. As you can see from here, we are just simply adding the input series. All right? And then right after that, we can reshape these three arrays of data as a single data set where each row is a time step and each column is a separate time series. And this is a standard way of storing parallel time series in a CSV file. As you can see from here, we try to reshape our input sequence 1 by the length of the sequence, which is equal to 9. And then the other one is the uh, 1, no, as the column, no, as the number of column. Since we only have one column for the input sequence, so that's our shape. It's 9 by 1. The other one is also the same. It's 9 by 1. And our output sequence is also 9 by 1. Now we have to stack them horizontally. So we are using the function hstack here. And as you can see, our input parameters for that is input sequence 1, input sequence 2, and our output sequence. Now, the complete example is listed below, as you can see, now for multivariate data preparation. So we need to define our input sequence first, followed by converting it into a row and column structure. So this is our row, and this is our column. 9 is the number of rows as the number that we have, and then 1 is the number of column for each input sequence. Now, and then we are going to horizontally stack them together. So you can see here, if we try to print now our data set, we will have something like this. Now, this is the first input sequence, 10, 20, 30, 40, up to 90. And the second input sequence is 15, 25, 35, and so on. And as you can see, our output sequence is just the addition, no, the total of the 10 and the 15 equal to 25. And 20, 25 is equal to 45. 30 plus 35 is equal to 65, and so on. Now, running the example allows us to see this particular result, no? But definitely, if you would like to, um, feed, no, this data set into an MLP model, no, we need to provide a splitting of a multivariate sequence, no, into samples. Now, as you can see from here, we have followed the same function that we have, which is the split sequence. Our input parameters are still the sequences and then the number of steps. But you will notice that there is a difference now, no, in terms of the uh, input and output parts of the pattern. No? Because right here, no, originally, we are taking our sequence X, no, from the beginning up to the end only. But now we have another column to have, no, since we have two columns here for our input sequences. As you can see here, we have another column. So that is why we are also taking from the beginning up to the end, no? So you can see here our function now lies on this particular splitting of sequence function. And as you can see, that our pattern is typically different now from what we have, no? So we are trying to split this multivariate sequence into input-output samples, no, for the time series prediction problem that we have. So what we're going to have is that the only difference that you can notice here is this one, no? Because this is for the second column, and also for our sequence Y, we need to also provide the last element, no, for the last element for our pattern of the sequence. Again, we're still appending for the X and the Y, and we are still returning an array for that. So having done this function here, having placed this function here, now once we call that function later, somewhere over here, okay, and you can see that the the data set, or the sequence that we have, is the data set. And what is this data set here? We managed to horizontally stack the input sequence 1, 2, and our output sequence. And remember that this input sequence 1 comes from reshaping our initial input sequence, no, and output sequence. So again, we have 3 as the number of steps. And right here is the conversion, where we try to convert our data set into X and Y, no, putting our data set and the number of steps. So we need 3 as the number of steps, and we're printing now. As you can see, we're printing our data, not to summarize it. And we have a result that looks like this. So you will notice that if we have 10, 15, 20, 25, 30, and 35, we have an output of 65. Okay, that means that our shape is something equal to like this. No? So we have one sample with three columns at three rows, no? Three rows with 2 columns, or 2 as the number of time steps. All right? And then this is the other sample. This is the second. This is the third one. And then the fourth. Let me try to put the marker. That's the fourth one. And then this is the fifth. And then the sixth. Somewhere here is the sixth. Right? And then the last is 7. So that's why we have 7 by 3 samples in 2 time steps. All right? So that's what we have here. And now for our output, we have only 7 samples, as you can see. And our dimension is 7 by 1, which we know that we only have one column, no? So meaning that we only have a single value for each time step that we have. And here's the complete example of doing that. And as you can see, we provided an input of 3 samples. No? We have 3 samples, and each sample has 2 time steps as the number of time steps. All right? So given this 80, 85, 90, 95, 100, and 105, our expected value is that we need to total, no? We need to sum 100 and 105. So therefore, our expected value is equal to 205 as our simple MLP model for this multivariate problem. So as you can see, if we try to run that, that's our output over here. So we're expecting around 205 for this particular model. And let's see. Yeah, it's 205.10986. And even if we try to change the number of steps, now for instance, we make it as 4, and then of course, since 4 na yung number of steps natin, okay? So before it's 3, we need to put additional element, no, of the array here as our input value, because the number of steps is now equal to 4. Okay, so let's see now. So before we see that, let's try to put 4 here as the number of steps. No? So we can see what will be the shape of our data set. And as you can see from here, the data set becomes 6 by 4. So definitely we now have 6 samples, and each sample has 4 time steps. All right? No, 4 4 sample, no? So we have 6 samples, 1, and then we have 4 as the number of time steps, okay? And then for each sample that we have 2 as the number of steps. Okay, so we have 2 time steps for each sample that we have here. But definitely this is 1 and the other one is 2 until 6. No? So ganun din yung ating output. We have 6 by 1. So if you try to do that here, so we have to, if you try to run this, this will make an error here. No? So magkakaroon siya ng error because our input array here is not enough, I think. No? So let's see. So you can see that there is a value in the error because we cannot reshape array of size 6 into the shape. So the size of the array is 6, and it is asking for something like 1 by 8. So we need to provide additional information here. For example, we can provide 110, and then this one is 115. No, because I believe this is the next number for this. No, 80, 90, 100, and 110, and then what comes after 105, it's 115. So now we have 1 by 8 as an input array. If we try to execute it now, we will have a value of the sum of 110 and 115, which is equal to 225. And let's try to look at that if it is 225. Yeah, it's 226.4, which is very close to 225. So you can see that we are not actually focusing on the accuracy of the model, but our goal here is to provide an implementation of the MLP for multivariate time series. All right. So that's only for the multiple input. Okay. So we managed to discuss the multiple input time series using this one. What about the other one, which is the multiple parallel series? The multiple parallel series is an alternate time series problem. It is the case where there are multiple parallel time series and a value must be predicted for each. So meaning that we have one input, as you can see from here, we have an input of sequence 1 here, and we have another sequence here. So our goal here is to provide the output sequence. As you can see, our output sequence is that given the number of steps, for example, 2, yung number of steps natin, so the following will be our output, meaning we will just have 2, we have 7 samples now, and each sample has 2 columns, and we have 3 rows for each sample, meaning we have 3 time step for each sample. And as you can see here, that at each column, we are adding 10 and 20 equal to 30. We are adding 15 and 25. It should be equal to 40. So that is how we can see from it, but definitely that's not the case here. So you can see here that based on this, this particular example, what we're trying to do is to basically see the addition of every sequence. So ang sequence kasi natin, yung isa ay 10, 15, and 25. The other one is 20, 25, and 45. So kasi ganito yan So ang magkasunod diyan ay yung 10 and 15, yun ang magkatapat, 10 and 15. All right? And then ang magkatapat naman dito ay 25, So if you try to run this again, run this again, so you can see now that this one is the actual output, But if you try to make it 3 as the number of steps, no? Let's try to do that. So we have now the following, no? So based from what we have, no, let's say 10, 20, and 30, what comes after this sequence? We have 40. And what comes after 15, 25, and 35? We have 45. What comes after 25, 45, and 65? We have 85. So that's how it goes. So this is what we call multiple parallel series. Now we are expecting an output. No, we are expecting an output for every time series that we have, every parallel or multiple parallel time series that we have. Now we are actually predicting a value. So we're expecting something like that. So this is now the uh, the uh, the dimensions, no, that we have obtained so far. So we have 6 samples that has 3 as our number of samples, and each sample has 3 as the number of steps. Now, to complete the example, applying the MLP, as you can see from here, so we have this simple example as we have defined. And then and after doing that, we need to convert it again into a sequence, and we need to reshape by computing the length of the input sequence. That will be the column, okay? And that will be the length of the row, and the column is equal to 1, okay? And then we horizontally stack them together, no, and put them into a variable called dataset. Now, for this example, we have n number of steps is equal to 3. And then we're putting the input variable of dataset here as our dataset for our split sequence, and the number of steps is equal to 3. All right. So moving on, we need to flatten our input first. As you can see from here, there is an additional command that we need to do. We need to flatten the input. So now our n underscore input is equal to the second shape of our x multiplied by the third shape, no? And then our x now will be equal to the following, no? The first shape and n, which is the product of the second and the third index of our shape. And then this is our output shape, no? For the output shape, we have the following shape, no? We're putting the first index, or the second index for our shape, and that to define our model, this is just a very simple model for multi-layer perceptron, and we're putting our data set again. And then to give us an example, so definitely we have 6 by 3 here. All right, so we can now try to execute the following. As you can see here, it's executing. We managed to properly give the data set, and we are expecting that our answer would be 100. Yeah, that's 100. And then what comes after that, we need to get that's 75, 85, 95, 105. Okay, that's also okay. And then for this one, we have 145, 165, 185. We need to expect 205. So definitely the model that we have is predicting properly, no? So never mind the accuracy of the model, but we were able to predict our model right here. Okay, so far, if you have some questions, please feel free to provide your questions in the public chat so we can discuss it before we proceed with the convolutional neural network. The convolutional neural network is our second topic, no? So we still have one more topic left after CNN. Okay, moving on. If you don't have any questions, we proceed with the convolutional neural network. As we believe, no, CNN is a very specific type of deep learning model. Now, basically, we have understood before that CNN can be used for images, and maybe this is the first time that you will see that CNN can also be used for time series forecasting problem. Okay, and it can be implemented also in univariate time series forecasting. At the same time, it can also be applied in multivariate time series forecasting, and as well as multi-step time series forecasting. To give us an example of univariate CNN models, no, let's try to have a contrived data set. No, as given here, we have 9 as the length of the time series that we have. Okay, given the following sequence of 10, 20 up to 90, we have 9. Again, no, this is the function that we have built for our MLP. We can also use it for CNN, and again, we can also use it later for the LSTM, no, that we have. So what we're doing here is to split our data set, no, according to the input parameter sequence and the n number of steps, and we are returning an array of X and array of Y for our data set. So you can see from here that this is the as we have defined, the number of steps is equal to 3. So it provided 6 as the number of samples, and for each sample that we have 3 as the number of steps, 10, 20, and 30. And then the 40 here is our output value, which is the next to the range of our time series, and so on. Okay, so to give you an example of that, no, so applying the convolutional neural network, of course, we need to import our libraries. Now we need to import sequential, dense, flatten, and we also need to import the keras.layers that convolutional, the convolutional 1D and the max pooling 1D. So this is just a very simple CNN model that we are creating. So again, this is the function for our data preparation, and this is our input data set. The number of steps is equal to 3, and then after that, we split our data set into samples, no, for the row and the sequence, and we're calling the function split underscore sequence. We are printing also the data set, so make sure that we have properly selected the um, um, the number of sequences. And then before we define our model right here, what you notice is that we have another thing to do before we proceed with the creation of the model. What we need here is to reshape, no, from these two sizes of samples and time steps, we need to convert it into 3 sizes, namely samples, time steps, and another feature, no, was added, which is the features, no. And for this, we need to provide the length or the number of features that we have. And in this case, we are just initializing the number of features is equal to 1. Okay? And we also need to reshape our X. We need to reshape our X. Remember that here we have our X will be equal to the number of samples and the number of steps, correct? But here we are reshaping it in such a way that it will have 3 dimensions, namely the first index, the second index, and the number of features, which is equal to 1. So now the X now becomes 3 dimension, and it's now ready for deployment for our model. Okay, so the model is simple. As you can see from here, we have just one convolutional layer here, one max pooling layer, one flattened layer, one hidden layer here, and one output layer here. All right, so the number of epochs is equal to 1,000. And for our input variables, no, we have provided 3 time steps. Now, one sample with 3 time steps of 80, 90, and 100 respectively. Again, we need to reshape, no, in such a way that our input size will be equal to the desired value for our CNN model, which is the 3 sizes. This is the number of features. This is the no. This is the number of what do you call this? The number of the shape. No, the shape of the first shape, and then the number of steps, the n number of features here, and then we print the prediction after that. And as you can see from here, our expectation is that after 80, 90, and 100, we are expecting 110. Correct? Now we'll see now if it's going to have 110 as our output value. And you will notice that we have 112.7. So medyo sumobra lang siya ng konti. Pero definitely, our model is working. What if we change it, no? So let's say we want to change it. Maybe I want 55 here. And I want 65 here. And I want 75 here. Our expected value should be equal to 85, right? Because we notice that the interval of our raw sequence variate time series is in an interval of 10. Therefore, our model should learn that after 55, 65, and 70, the model should be able to predict that the next number is equal to 85, more or less. Okay, let's try to execute. And as you can see, we are able to demonstrate the prediction, and the answer is 85.105. All right, so we managed to give an example for univariate, and we managed to provide an application of a CNN model. Now let's proceed with multivariate CNN model. Again, multivariate time series, when we have two or more observation for each time step, that means we have a multivariate time series data. And we can apply that with CNN model. But before we proceed with that, there are two main models that we may require with multivariate time series data. Same as MLP, we have multiple input series, and we also have multiple parallel series. Now, you can see that the multiple input series, no, is the same in the preparation of the MLP, right? And you will see that the sequences and the number of steps still the same, and we still need to have a second column here for the sequence X, second column for the sequence Y. All right. So given the following values for input sequence 1 and input sequence 2, we are just trying to add, no, the every aspect, no. So for each time step, we're trying to add the input values for input sequence 1 and input sequence 2. That means 10 plus 15, our output should be 25. And 20 and 25, our output should be 45, and so on. All right? And then we will try to reshape it again. As you can see from here, we're just copying and pasting. And then we horizontally stack the data set so that we can provide a proper data set for our context. Now you can see that this is now our data set. No? Given 3 as our n number of steps, the following now is the shape of our data set. Right? So you can see here that our expected output, no, is the total of 30 and 35. The second sample is 85 as our output. It's because it's the sum of 40 and 45. And until the end of the samples that we have. How many samples we have? We have 7 samples. Okay. Now, here's a complete example of applying the CNN. And as you can see from here, this is the output. We are expecting that if we have 80 and 85, 90 and 95, 100 and 105, our expected value is the total of 100 and 105, which is equal to 205. And as you can see here, everything is fine. We are demonstrating the prediction as it is expected. Now, what about multi-headed CNN model? So this is another way, an elaborate way to model the problem. Now, each input series in a multi-head can be handled by a separate CNN model, and the output of each these models can be combined, no, by way of applying a typical function called concatenation, no? So which means now before the prediction is made for the output sequence, we try to combine the separate models, no? And this is what we call the multi-headed CNN model. Below is an image of that. No? As you can see, we have model 1 here, and another model is given here. And then at the middle, we were able to combine them together. And at the end, we were able to have our output models here. So to be able to do that, let's see this example over here. No? So ang example natin, we have two models. So we have first input model. So we name the visible one for our input layer. No? So you can see that the input is our input layer, and the shape of that is n number of steps and n number of features. So it's a 2-dimension. Okay? And then this visible one will also be an input of our hidden layer. So this is our hidden layer number 1, CNN1. So we have a 64 as the number of filters, 2 as the kernel size. Our activation function is ReLU. And then you will also notice that the visible one, which is our input layer, is also an input, no, for this particular hidden layer. Another layer is the max pooling layer. But you will notice in the max pooling layer, along with that, we are trying also to put our CNN1 as our input. And then this, supposedly you can create it like that, no? But if you want, you can change the names, no, so that it might not confuse you. But you have to make sure that the input of this is the previous one, no? The input of this is the previous one, and this one should be the previous name of this. It's a different type of deploying or creating a model, no? Kasi nasanay tayo yung model na ginagawa natin before is the sequential type, no? So this one is a bit different. So the same with the second. It's the same with the second input model. We have visible 2 naman, no? Visible layer number 2, which is our input layer number 2, and then this is the hidden layer number 2 for the second input model. This is the max pooling layer, and the flattened layer goes here. All right. So that's our first input model, the second input model. So what happens next is we need to combine them together. No, we have to merge the input models. That is why we are using the function concatenate. So you can see the input of our concatenate is CNN1 and CNN2. That's our flattened layers. No? So ito yung huli natin na CNN2 at saka huli natin na CNN1. Those will be our input for our merging. And that merge variable here will be an input to our next hidden layer. Okay? So this is another hidden layer here. So in the image, you will notice that this is the that image, no? That particular image there. And then the output layer, which is equal to dense, no? Yung hidden layer na yan ay magiging input sa ating output layer. No? And our output is going to be the output. Okay? Now, for the model, no? To tie the inputs and outputs together, to create the model, you can see that this is the model. And then we're calling the function model. And for the inputs of that, we need to include the visible one, which is equal to the visible one, the input. And the other one is the input for the second input model. And then for the outputs, our output will be equal to the output, no, which is probably after we have merged our input models. All right, so that's all for summarizing, no, how we were able to merge the two parallel inputs together. No? And here is the complete example of a multivariate, multi-headed, one-dimensional CNN example. As you can see, we need a lot of importations to begin with. And then this is the splitting of the multivariate sequence into sample. Now, as you notice, Ito pa rin yung ginagamit natin. This is the updated version where we need the second column, right? And then to define the input, so let's say we have input sequence 1 and input sequence 2 here. All right? You will notice na meron na tayong mga bago dito, no? So you can see na we need to provide, wala pa tayong bago pala dito so far. But ang bago natin is this one, no? Yung we need to reshape our x1 and x2 in such a way that the x, no, na ma-obtain natin from our data preparation, kailangan natin siyang i-reshape into the following. X1 should be reshaped into the first shape of the X, the second shape, and the number of features. Secondly, the X2 should have to be the same, but you will notice that this one is for the index 1, and this is the second index. Okay? Now, this is our visible layer. Ito na yung model natin, no? And then this one is the merging. And then the compilation of the model goes here. The fitting of the model, notice that the input variables for training the model is x1 and x2. And then to demonstrate the capability of our model, since alam naman natin na ito yung magiging output natin, no? So we need to provide the following samples, no? So what should be the expected value? We are expecting a 100 plus 105, that's going to be 100 and 205. And you notice here that that's supposed to be our expected value. And we try to run it again. No? We'll see if it's working properly. Definitely, it's now working because it's now 205.83. Now, what about multiple parallel series? So this is an alternate time series problem, and this is the case where there are multiple parallel time series and a value must be predicted for each. No? So basically, ito rin yung the same natin kanina na diniscuss sa MLP. No? But this time, and you'll notice na nag-iba na naman, nag-update na naman yung ating function in such a way na ang gagamitin naman natin dito, instead na kukunin natin yung last value, we are getting everything, no? From the beginning to the end. From the beginning to the end. So we're getting everything here. Okay? So this is the way that it will go. You will notice that it will produce, depending on the number of steps that we have designed. And in this case, we have n as the number of steps, meaning each sample that we have will have three samples, no? Three samples, and each sample will have 3 time steps, the number of steps. So definitely, it will provide an input value of 6 by 3 by 3. So ito yung pagkakahati niya, 6 by 3 by 3. So we have 6 samples, 3 columns, 3 rows, and then for our output, we have 6 by 3 because we have 6 samples, and each sample has 3 as the number of steps. Right, so moving on, let's try to have our complete example. As you can see, so the convolutional layer that we use for multiple parallel time series is the same, but we managed to just use a simple convolutional layer for this. No, this is not the same with the other one. No, and to demonstrate, so since kailangan natin ng 6 by 3 by 3, so we need 3 samples of 3 time steps per each sample. And if we have this particular example over here as our expected input, our expected output should be equal to something like 100, no? And it should be 105, and the other one is 205. Okay, and it is, right? So it should be 70, 80, and 90. The next is 100. 75, 85, and 95. The next is 105. 145, 165, 185. The next should be 205. And those are the prediction. Medyo malayo lang, but we managed to be able to do that. So let's try to do it again. And let's see the prediction of the model that we have created. All right, so we have 101, we're expecting 100. 106.67, we're expecting 105. And 207.98, which is very close to 208, and we are expecting 205. So medyo may mga konting kalalabisan dito, pero our goal here is just to definitely apply the model based from the data that we have prepared. Now, what about multi-step CNN model? In practice, there is a little difference to the one-dimensional CNN model in predicting a vector output that represents different output variables, as in the previous example, or a vector output that represents multiple time steps of one variable. Nevertheless, there are subtle and important differences in the way the training data is prepared. As you can see from here, we are now updating. Again, take note, we are updating our function here, which is the split sequence function. So before, we just have sequence and the number of steps. Here, because we're talking about multi-step, we want to identify the number of steps in, and we also want to identify the number of steps out. So these are the three parameters that we will be using as our input to the split sequence function. And you will also notice that we have the simple, this is just the simple function that we have earlier for sequence X. But this is for the input, For the input, we have end IX. So this is our end IX. And the end IX is equal to I, which is the current iteration, plus the number of steps in. For the out end IX, that will be equal to end IX plus n number of steps out. So the sequence for the Y will be equal to the following, beginning from the end IX up to the out end IX. So what will be the input parameters of our split sequence? Again, we have the data set, the number of steps in, and the number of steps out. And you will notice that we have provided the necessary value for the steps in and for the steps out. So here we have 3 by 2. So yung 3 by 2, ganito itsura. So if you try to change that, if you try to do that, we will have a shape of 5 by 3 for the input, and for the output, we have 5 by 2. Pero pwede mo rin baguhin yan. Pwede mo ang gawing 2 yan, pwede mong gawing 3 yan. Okay? So, if you try to do that, we will have the following. As you can see, nabaligtad naman siya. Ang input natin is 1020. Our output is 5 by 3 or 3 steps. Okay? So here we can dictate whatever steps we need, Now, as an example, if you have a time series of demand for electricity perhaps, and your time series is measured in terms of hour, so meron kang 24 hours. So meron kang 24 na time series data. So another day, 24 hours din. So 24 din yung demand. So ang goal natin sa demand forecasting, for electricity perhaps, let's say you want to forecast the next 3 days or the next 1 day or 24 hour. So this is how we do it, So pwede mong baguhin kung per hour yung dataset mo, gawin mo na halimbawa yung dataset mo, yung number of time steps mo is 24. Okay? So here pwede mong gawin na yung number of steps out mo ay equal to 12 perhaps, no? This is a half day forecast, no? Kaya lang hindi natin pwedeng i-implement to dito, no? Kasi maigsi yung dataset natin. So mag-e-error po 'yan. Wala tayong makikitang output niyan, 0 'yan, no? Kasi maigsi yung dataset natin. But if you do have, sabi ko nga kanina, if you have a dataset for demand forecasting for electricity na meron siyang time series record for a whole year, for example, and you want to predict the next 24 hours or the next 48 hours or the next one whole week. So, pwede mong ilagay dyan yung number of steps in na pwede mong i-feed sa model mo and then the number of steps out na pwede mong gawin sa model mo. But for the meantime, let's settle for this, no? That we want, for example, we want 4 as our steps in and we want just 2, no? For the steps out. So, kapag niran natin yan, ganito yung magiging shape ng model natin. We have a 4x4 and for the output, we have 4x2. Meaning, meron tayong 4 na output and each output has 2 as the number of steps. No? Okay? So, here is an example. You notice na dito, our example has the following values. So again, the function that we have, we need to split our data set. And you notice na ito na yung ginagamit natin. No? Similar doon sa taas na diniscuss natin. Now, let's have the following. And we want to forecast 3x2. No, for the number of steps in and 2 for the number of steps out. Okay? And then we provided the model. Our sequential model is CNN, no, for the convolutional neural network model, and we are expecting that our given that we have 70, 80, and 90, our expected next 2 time steps out is 100 and 110. At tumama nga siya. As you can see from here. No? Ine-expect natin na ang susunod dito ay 100 and 110. Okay? So what? Medyo malayo, no? 103 to at saka 140. But definitely, nakakapag-measure tayo, nakakapag-predict tayo ng values. No? Kahit medyo malayo, nakakapag-predict tayo. Okay? So, halimbawa, ito, no? So, meron kang 100, 110, and 120. We are expecting 130 and 140. Correct? So, tingnan natin yung prediction niya. 130, 100, and dapat 140, no? Medyo malayo na to. So, masyadong malayo yung ating prediction. Pero it's okay because we were able to predict, no? Although the error in terms of prediction is very high, no, compared to what we are really expecting. Okay? Now, what about multivariate, multi-step CNN model? So here, what we're trying to do is just a univariate. What if we have multivariate, multi-step CNN model? So in the previous section, we have looked at univariate, multivariate, and multi-step time series forecasting. It is possible to mix and match the different types of one-dimensional CNN models presented so far for the different problems. This too applies to time series forecasting problems that involve multivariate and multi-step forecasting, but it may be a little more challenging. And in this section, we'll try to explore short examples of data preparation and modeling for multivariate, multi-step time series forecasting as a template to ease this challenge. Specifically, we try to evaluate the multiple input, multi-step output. So medyo confusing lang yung mga terms. Multiple input, ibig sabihin maraming input. And then yung output natin should be multi-step. So pwedeng isa, pwedeng dalawa, pwedeng tatlo. The other one, what if you have parallel input? Okay, you have input sequence 1, input sequence 2, and then you are expecting one or more output. That's multi-step output. Okay? So, how are we going to do that? Again, so mapapansin nyo dito, ito pa rin yung ating split sequence na function. So, we have the end, the start, and this is for steps in, no? And then this is for the steps out. Okay? But here you notice na nag-subtract tayo ng 1 dito. No? Nag-subtract tayo ng 1 dyan. No? And then dito, sa pag-gather natin ng input and output parts ng pattern, so medyo we just need everything except the last. No? Everything except the last. Okay? To demonstrate, that's the essence of our expectation is that we will be able to create something like this. So 6 by 3 by 2 and 6 by 2. All right. So that's our output for this particular example. So what we are expecting kanina, meron lang tayong input na 6 by 3 by 2, pero ang output natin kanina is 6 by 2, no? But here, we want an output of two time steps, no? Yung output natin is dapat dalawa siya, no? But here, we are actually doing it for multiple input parallels, no? So bale ang input natin may input sequence 1 tayo, may input sequence 2, and meron tayong output sequence. Okay? So bali yan yung ating output. Okay? So this is the complete example. So you can see that we have performed and then we predicted. So halos mapapansin nyo, pare-parehas yung ginagawa natin. Pero dito lang yan nagkakaiba-iba sa function on how we prepare the data. Depending on the type of time series data that we are trying to do. For instance, dito napansin niyo yung kailangan natin na steps in ay 3 and the number of time steps that we need is 3. So in this case, ang kanyang hatian will become 5 by 3 by 2. So ibig sabihin, we have 5 samples. Each sample, meron siyang 3 samples each. And each sample sa loob, we have 2 time steps. Now for the output, we have 5 samples and each sample has 3 times as the number of steps out. So ito kasi steps into di ba? Ito naman, steps out. Okay? So our expected value is the, we are expecting to have 185, 205, I think, tingnan natin. Wait lang ha. So we're expecting an addition of what? So kasi itong 125 na to, so galing siya dito, no? 125. And then ito namang 145, galing naman siya dito sa output na to. Yung 165, no? So again, ulitin natin ha, paano ba niya ginagawa yung mga susunod na time steps niya. So bali ganito, pag nakuha niya yung output nito, no, yung addition nito 65, mag-a-add siya ng 20, mag-a-add siya ng another 20. That should be the output of the ano. So dapat 20 yung interval. So ito, if the output of this is 145, so 165 and then 185. So our expected output given the following, no, ito given the following, our expected output is 185 and then yung susunod natin should be 205 and then 225. So parang medyo malayo yata siya, no? So tingnan natin mabuti, i-run natin siya uli. So our expected is we will have 185 as our first value and then 205 for the second, and 225. No? Pero to sobra-sobra, no? Sobrang malaki ng ano niya dito sa third step niya. Third step out niya medyo malaki na. Okay? Another one is multiple parallel input and multi-step output, no? Sabi dito, a problem with parallel time series may require the prediction of multiple time steps of each time series. For example, consider halimbawa meron tayong ganitong multivariate time series, no? From our prior section. So actually pwede kong ayusin to. Hindi na siya naayos. So anyway, so halimbawa ganyan yung ating arrangement, no? So an example of that is the following, no? So our goal here, as you can see, our goal is to get two samples, no? Two samples na merong tatlong time steps. So mapapansin niyo yung input natin is 5/3/3. At the same time, yung output naman natin, dapat ang output natin, meron siyang two samples. And each sample will have 3 time steps. So ito yung ating makikita rito, no? As the number of steps here. Okay? So yan yung number of steps natin. Ito naman yung number of steps out, 3. And the other one is 2. So kung babaguhin natin yan, it will make a difference, no, in terms of the output. So halimbawa, ginawa mo ring 3 yan. So the output will be different, no? So magiging 4/3/3. At the same time, ganun din yung output niya. So 4/3/3. So if you're going to make this as 4 as the number of steps in, so it's going to change, no? 3/4/3, and the output is equal to 3/3/3. Okay? So yan yung output natin. So baguhin lang natin, gawin lang natin 3 to, and at the same time, dalawa lang yung ating steps out. Okay? So that's the difference now. Okay? So just try to save our file. And just try to save the file para ma-update yung ating mga changes. So this is a complete example of the example that we have. So here, our goal is to have 3 samples or 3 time steps in and 2 steps out, no? So given the following input values, our goal is to produce an output na merong 2 samples na may 3 time steps. No, parang ganito. So meron siyang tatlo na tigka-3 number of steps, 3 sample na each sample has 3 time steps in. So 10, 15, 25, 20, 25, 45, 30, 35, 65. So the next would be 40, 45, 85. No, and then the next is 50, 55, and 105. So nakikita ninyo na if you take a look at the column-wise, ang interval is 10, no? 10, 20, 30, 40, and 50. Ganun din yung second column natin, no? For the second input sequence. 15, 25, 35, 45, and 55. For the third column, which is the output sequence, no? The interval is 20. So, yan yung ating interval. So, getting from here, 60, 70, and 80, our output, no? Ang ina-expect nating output ay ito. Ang ina-expect natin, ang output natin would be equal to the following, no? So, dapat ganito yung output natin. So, dapat meron tayong output na 90, and the other one is 95, and the other one is 185, no? And the other one, no? yung isang output natin, kasi dapat dalawa yung output natin, di ba? So the next output would be 100, and then 105, and then the other one is 205. So pag niran natin to, yan yung expected natin na i-output sa atin. Right? Let's see. So tingnan natin kung similar siya sa magiging output natin, or there's a little bit of difference maybe, but we are not concerned on the error, no, in terms of the difference. Let's see now the answer now ready to pop out. All right, so we managed to get 90, 95, and 185. And then we managed to get 100.5, 100.06, and 206.05. Definitely, it's really close to what we are expecting. Okay, now here's a real-time or real-world data set. I'm going to provide these data sets. Now, if you don't have these data sets, I will put it in your module. So I'm going to put now this in your module. So tatlong data set yan actually, no? So we have the following files. So just check sa module nyo para makita nyo yung ating mga files, no? So this is the module. So from the downloads, we have, okay, wala. Wala pala dito. So let me download the data set, especially the shampoo data set. So I think it's the shampoo data set. I have it here in my Colab notebooks, and then data, what else? So the shampoo data set, so I need to download it. So this is the shampoo data set. Download. And then I need also to download the AAL us.txt. And the last one is the household power consumption. Yan. And then I'm going to upload those files dito sa module 12 as files. So paki-check nyo na lang kung makikita nyo siya dito sa module nyo. And basta in-upload ko na yung mga dataset na gagamitin ko for this demonstration and explanation. Now, for this first example of a sample for a real-world dataset, particularly univariate, we are expecting the shampoo dataset. Now, shampoo dataset is a very simple example of a univariate. No, we have a time series. No, we're in. I think it's just 3 years. So, bali 36 lang yung number of rows niya. And then for each month, there is a corresponding value equal to the sales of the shampoo. Okay? So the first thing that we will do is to load the data set. You can see from here. And we will just take the feature. The name of the feature is, or the column, the name of the column is sales. Now, we are not concerned with the month. No? So, bale, ang gagamitin lang natin is the value, no? The feature with the sales. So what we are trying to do here is to predict what will be the sale of the shampoo after another month. Maybe we're expecting a sale of something like this, and maybe this model that we will be creating could help. No? So to manage the data preparation, we're still using the old split sequence function. This is the first one because this is just a univariate data set, no? And then the number of steps that we have is 6. So meaning, if this is our row sequence with 36 rows, the number of steps is equal to 6. And what we'll be using is a convolutional layer. Again, the number of features is equal to 1 because we only have one column. And then the shape will be equal to the first shape of the input layer or the input data, the second shape, index 2, and then the third shape is the number of features, which is equal to 1. Now that we have that, we can now deploy it using the convolutional neural network. And given the input values, no? So, given the input values, so what we are expecting are the following. So, ano kaya magiging output natin given the following, no? So, makikita nyo rito na ito yung mga output niya, no? And to demonstrate the prediction, so bali yung ginawa natin, no? Kung ang input value natin ay 437.4, 575.5, and then 407.6, 682, 475, 581. Bale, actually, ito yan, no? Ang ine-expect natin, 646 ang output niya. Kaya lang, nung nag-demonstrate tayo ng prediction, we only got 605. So what happens is that we managed to predict, but ang prediction natin is medyo malayo doon sa expected output natin. Okay? So kahit halimbawa ito yung gamitin natin, no? So ito namang isa, no? Itong isa, yung array na to, itong pangalawa. No? Halimbawa, ito naman yung maging input natin, no? Pwede naman, no? O kaya pwede kang manghula kung ano yung mga susunod na time steps. Okay? So given the halimbawa, ito yung sunod-sunod na value na binigay natin, no? So sige, subukan muna nating i-run, ha. Yan. So ang value na in-expect natin diyan, given doon sa input value, dapat 646. Paano kung halimbawa, no? Kakopy ko lang to, guys, ha, to demonstrate the prediction. I'm going to create a code here and put it here. Ang kokopyahin natin is this one, no? From this one, 575. So bale, buburahin natin yung first input value natin, and then the last value that we will have is 646.9. So bali, ang pinipredict natin dito is one step, no? Ibig sabihin, if this is the last month's prediction, ano yung susunod pang prediction after that? So ito na ngayon yung prediction natin. We can say na ito yung magiging prediction niya, pero hindi natin alam kung accurate yung prediction natin o hindi. Alright? So hindi natin sure kung tama yan, but we were able to proceed with the prediction. Now, another data set is AAL data set. So basically, AAL is I think this is a stock market prediction. So you can see that we have a date, no? From 2013 to 2017. In total, we have 989 rows. It has 7 columns, but we don't need all the columns. So we need to remove the date and the last column here, no? Which is the open int. Kasi lahat ng value ng open int ay 0, so it doesn't mean anything. So what we just need is to use the open, the high, the low, the close, and the volume. Alright? So what we do is to set the date as the index para hindi siya mapasama. And then we try to locate, we use the iloc, no, to just pick the following values, no, open, high, low, close, and then the volume. No, except the open int, no? Ito 'yon, yung last value natin. Hindi natin siya sinama. Okay? So our data set now will contain the following. It has 989 rows and has 5 columns. So multivariate, no? Multivariate. In some cases, para gumanda yung data set natin, since napapansin niyo yung open, high, and low and close, medyo lapit-lapit yung values niya. Pero sa volume, medyo malaki yung value. If you're going to plot that, medyo mataas ang volume. no? Masyadong malaki ang volume compared sa prices ng open, high, low, and close. So, ang ginagawa ng iba dyan, nino-normalize muna yan bago nila i-convert into NumPy. Pero dito, ang ginawa natin, we did not normalize the data. We just convert it into NumPy values. No? So, convert natin siya into NumPy values, yung dataset natin. And then, since multivariate siya, no, multivariate po siya, so what we did is to convert or to split our data into number of sequence, number of steps in, and number of steps out. Okay? And then this is the output. As you can see, medyo mahaba tong output niya. Yan. Mahaba kasi 989 yung combination eh. So, mababawasan lang ng konti yan. So, napakarami yan. No? I don't even see the end of it, no? Ayun, sa sobrang haba, lumagpas na tayo. Alright, so moving on, what we'll be doing next is to assign and reshape our input data. So, kukunin natin yung first index, tsaka second index, and then the number of features, which is equal to 4. No? Kasi 4 lang yung magiging input value natin. No? 4 yung magiging input natin. So, what we're looking at here is the, what we're looking at here, as you can see, is what will be the volume, no? Given the following example. No? So kung ito yung array natin ng input values natin, ito yung magiging output natin. Alright? So that's how we can implement multivariate CNN for this particular example. So meron nasa notebook naman to. And the other notebook is more complete, no, than this notebook that I am showing you. So the other one is the house power consumption dataset. So basically, ganito yung itsura ng dataset natin, no? So we have how many columns that we have? No, plenty, no? So I think this is around 9 columns, 1,168 rows. Again, we drop. Now, we're actually not dropping the date time. We just make it as an index para hindi siya mapasama sa columns natin. And then we remove the last submetering, no? Which is submetering 4. Kasi yung submetering 4, sobrang laki ng value niya. No, we're not using it. So what we're using are just how many columns? 7 lang. Now, we again converted into NumPy, and then we managed to prepare the data. Number of steps in is 3. Number of steps out is 2. So, the following will be our content. No? So, medyo marami yan. No? So, hindi ko na papakita lahat. Pupunta na tayo dito sa next part, which is the model, no, that we have created. And then, fitting the model by 2,000 epochs, and then providing the demonstration for the prediction. For instance, you have these arrays here, no? For the input values, we are expecting that we have this following predictions, right? So, any questions so far? So, medyo mahaba tong topic natin, no? Medyo mahaba. Because we still have one more topic left, which is the LSTM. Alright? So what about the LSTM? No? So remember the topic that we discussed about long short-term memory. Now, people doesn't have or do not have a long short-term memory. Siguro konti lang yung taong may ganito, no? Na very long yung kanilang short-term memory. We usually forget things, no? In our memory, it's very short, but we always remember what we have done 10 years ago. That's long time memory. We call it long time memory. And in deep learning, the capability of LSTM is suited for remembering the previous time steps, no, in order to predict what will happen next. So we can implement LSTM for univariate, multivariate, and at the same time multi-step time series forecasting. As an example, again, hindi ko nahahabaan ang explanation ko rito. Papakita ko na lang sa inyo what are the things that are given here. We have the data preparation, which is similar kasi univariate lang naman yan. Given the example, we have the following output. But in the implementation of the model, it is called vanilla because it's very simple. We only have one hidden layer of LSTM units, and we have an output layer. Let's make it vanilla LSTM. So if you try to apply that, pwede naman, no? So you can see, it managed to predict the next value given yung input natin is 70, 80, and 90. We're expecting 100. That's the vanilla LSTM. When you say stock, no, ang ibig sabihin ng stock, LSTM layers that you see are stacked one on top of another. Kaya tinatawag siyang stock LSTM model. Okay? So, an LSTM layer kasi it requires three-dimensional output. So, makita niyo yung input shape niya, end steps, and end features. So, kailangan mong i-convert ang dataset mo in such a way na katulad nito, no? This is a univariate. Kailangan natin siyang i-define something like this. And this was able to correctly predicting the output of our input example. Now, what about bidirectional LSTM? No? In some sequence prediction problems, it can be beneficial to allow the model, especially LSTM, to learn the input sequence both forward and backwards and concatenate both interpretations. So, ang tawag now natin dyan ay bidirectional LSTM. And we can implement a bidirectional LSTM for univariate time series forecasting by wrapping the first hidden layer. As you can see from here, we are wrapping it with the function called bidirectional. Okay, so before you implement the LSTM layer, you have to wrap the layer with bidirectional function. So ang tawag natin dyan, bidirectional LSTM. So that will be learning the input sequence from the forward and at the same time, no, backwards. And it will concatenate both interpretations. So this is an example of that. In case you will need to implement this in the future, you will have an example. Now, another version of LSTM is the combination of the capability of the CNN or the convolutional neural network to extract and learn feature from the one-dimensional sequence of a univariate time series. So, ang concept ng CNN, di ba, nakakapag-extract siya, tsaka nakaka-learn siya ng feature. Tapos, dagdagan mo pa ng capability ng LSTM as the back-end, no? So, ang gagawin natin, si CNN na mag-i-interpret ng subsequences ng input, no? And then si LSTM naman ang mag-i-interpret. Kaya naging hybrid siya. No? Tinawag siyang CNN LSTM. So ganito lang ang kanyang application. So makikita nyo rito sa model, we are using time-distributed function as the wrapper. So ano mga input niya? Ayan, no? Ganun din. Basta lalagyan mo lang ng time-distributed, ang tawag dyan ay CNN LSTM. That will be for the CNN model. Kasi ang magiging input natin ay CNN model at ang magiging output model naman natin ay LSTM. Alright? And then this is the output layer of the LSTM. Okay? So this is the complete example in case na gagamitin nyo siya in the future. So ayan, nakapagka ano na siya. Now another type now related to the hybrid version of CNN LSTM is the conv LSTM. But here, hindi mo na kailangang gumawa pa ng time-distributed CNN and then you have to include LSTM sa output layer, no? Kasi tong conv LSTM, no, meron na siyang built directly into the LSTM unit. No, meron talagang conv LSTM na function. Okay? So makikita niyo yan dito sa baba. But you need to reshape. Ang problema dito, kailangan mong i-reshape into 4 shapes. No? Tingnan nyo, 4 na ngayon yung ating dimension. No? Ayan, okay. Napansin nyo rito, conv LSTM 2D. So, ilan yung kailangan niya? Dito sa input shape, 3 na. Kasi kailangan mong i-reshape yung X mo sa 4. First shape, second shape, n number of steps, and n number of features. Okay? Ito naman ang complete example niyan para kung sakali na implement nyo siya in the future. Okay? Multivariate LSTM models. No, kanina, puro univariate ang pinag-uusapan natin. This time, we're concluding our topic. No, malapit na tayo matapos. We're concluding our topic into multivariate LSTM models. So again, if CNN has multivariate CNN models that has multiple input series and multiple parallel series, meron din si LSTM yan. Okay? So, ito naman yung example natin sa multiple input series. So, again, ang purpose natin sa multiple input, now, kino-concatenate natin, hindi natin kino-concatenate. We are expecting at each time step, meron tayong addition ng parallel inputs natin, no? So, i-reshape natin siya, horizontal stack. Basic lang yan, katulad ng ginawa natin kanina. Ganito yung ating dataset. Ito yung implementation ng preparation. So, ito naman yung ating output. And using the LSTM model, yan. So, basic lang yung LSTM natin. Vanilla lang to. No? So, kahit na multivariate pa yan, pwede natin siyang gamitin, no, for LSTM model. Okay? So, given this example, input parameters, our expected value is 185, which is correct, no? What about multiple parallel series, no? Ibig sabihin ng multiple parallel series, meron tayong multiple inputs, and then each input, we are expecting an output. Okay? So, hindi natin sinasum o hindi nakarela yung output natin sa input sequence natin, kundi bawat input ay may sariling output. Okay, so ito naman yan. Okay, so yan yung example natin. Actually, na-explain na natin yan kanina. Ang implementation na lang ng, at ito daw ay pwede nating gamitin. Remember, ito ang dapat nating tandaan, no? Yung application ng ganitong klase ng variety ng data, no? Kahit na anong klaseng LSTM pwede nating gamitin. Pwedeng vanilla, pwedeng stack LSTM, pwedeng bidirectional LSTM, pwedeng i-combine mo pa siya sa CNN, pwede rin siyang conv LSTM model. So in this example, gagamit lang tayo ng stack LSTM, no? Where the number of time steps and parallel series features are specified for the input layer via the input shape argument. So this is an example. Check nyo na lang. Nasa notebook naman yan. No? Okay, so we have a stack layer of LSTM, and this is our input parameters. Given these input parameters, what are our expectations? Our expected values are 100, 105, and 205. What about multi-step LSTM? So sa LSTM, same lang yan sa CNN na merong multi-step. Pero sa LSTM, pwede natin siyang tawaging vector output at saka encoder, decoder, model, no? Or model. Yan. Now, dito sa data preparation ng ganitong klase ng dataset na multi-step, kailangan natin ng 3. Multi-step, so ibig sabihin may steps in tayo, may steps out. Okay? So again, ito yung example natin. If we have 3 as steps in and 2 are as our steps out, magke-create siya ng 5 samples ng input natin. So 5 by 3, no? So 5 by 3 ang magiging output natin is this is a 5 by 3 by 3. Okay? And then what do we have? For the output, we have 5 by 2. Okay? Ito yung example ng vector output, no? So kailangan natin ng kailangan nating gamitin tong function na to. Okay? So definitely we need steps in and steps out. So you need to provide also the steps in and steps out here. And then we use just the stock LSTM for this particular example. And if you are given 70, 80, and 90, we are expecting 100 and 110. So dito, ang output niya is 101 and 112. What about multivariate, multi-step LSTM? So this time, we are dictating how many output do we need, no? So dito, we'll be applying problems that involve multivariate and multi-step forecasting, no? And this is a little bit challenging, no, in some cases, especially if you have large data sets, no? So mga ganitong example na very contrived ang data set natin, napakaliit, no? So medyo madaling maintindihan, kaya dito natin dinala yung ating explanation. But when you try to do it in large data sets, so medyo nakaka-confuse na to. But again, just follow the simple way to split your data sets. Ang nakaka-confuse na part is here, no? Because you need to implement multivariate. So ibig sabihin, you need to provide x1 and x2 as your input values, no? For especially for LSTM, no? But here we did not implement that, no? All right. So are we still good? I think we are still good. So I'm okay, kala ko ako na lang ang nagsasalita rito. Kasi nalobat na yung yung headset ko. So I'm now using the mic and the speaker for the laptop. So anyway, malapit na tayo matapos. Just bear with me. And I'm going to give you the assignment. All right? So ayan. So these are the result of creating our data set in such a way that we are defining the number of steps in and number of steps out. And in this case, we would like to have 3 and 2 respectively. So these are our output values. And this is the complete example. Okay, given this, what will be our expected output? Our expected output is that we have 100 and 105. 100, sorry. It should be 70, 80, 90, and then 75, 85, and 95. So what will be our output, no? So our output should be, it should be around 100, no? Should be 100 and 125. So, yan. Okay? So given the following example, so if you try this, if we try to run, so and expect natin na 100 and 125, no, yung output natin. Is it? We don't know yet, no? So we just have to wait. Medyo mabagal na siya, medyo matagal na, meaning imagine if you have the real world data set, no?
So that will take time. Kasi ito, ang dataset natin is just the following, no? We only have this, no? So it's around 185. Ah, yeah, sure. It should be 185 and 205. So yung bali yung magiging next output natin should be around if we have an input, no, something like this, our expected output is 185, which is the total of this, total of 90 and 95 plus 20, which is equal to 205. So tama pa rin. Okay? Tama pa rin. So mali yung in-expect ko kanina. I cannot recall how the sequence was patterned. Now for the multiple parallel input, meaning we have input sequence 1, input sequence 2, and we are expecting an output sequence for each input. No? So this is an example of that. You can see now that we are getting everything, no, from the input and from the output as well. So this is an example of creating three number of steps in and two for the steps out. So you can see na ang ating output will be the following. So yung ini-expect natin, magkakaroon tayo ng dalawang output na merong tatlong time steps. Okay? So yan yung magiging output natin. So given the following example, if you have an input of this, ang ine-expect natin mag-output tayo ng ano ba magiging output natin? Let's say 100, 105, and 206. Okay, so again, this is very interesting to take a look at, no? And these are the references that I've used for this particular example. Okay, the notebook is already available. You can use it. All the data sets that I use are also uploaded. Now it's time to show the assignment, no, that you supposed to submit. All right. So the assignment are it's just a simple assignment for applying the no, this one. Yeah, this one is the assignment. So the assignment is about the demonstration on how to apply deep learning models for time series forecasting. So in the first part, you're going to choose any univariate dataset, so isang dataset lang, and apply MLP, CNN, and LSTM. It's really simple assignment. For the second part of your assignment, you have to look for a multivariate dataset, no, and apply MLP, CNN, and LSTM. It doesn't matter what type of CNN, LSTM, or MLP do you have, as long as you implement them. Now, for the multivariate data set that you have. And then submit for the submission, you need to submit an accessible Google Colab notebook. All right. So this is for next week. So check on the date. Please check on the date. We only have few meetings left. No, actually we do have two meetings left. No, 13 and the 20th of May. So next week I'm going to discuss model deployment because that's going to be your final exam. No, to deploy a model that you have. No, pwede nyong piliin yung mga model na provide you na before, but in terms of the model deployment, no, I'm going to talk about that next Saturday.